Welcome back, dear students, to this lesson of computer organization architecture, almost getting to an end. Today, we are going to look at the input-output interface and how the processor communicates with peripheral devices. An input-output controller can be described as an interface between the core computer system and its peripherals. If you remember very well on the diagram we had concerning the Harvard architecture and the von Neumann architecture, on there in between the processor and the input and output devices and even the storage devices, we had a controller, input output controller, and that is what we are going to look at today. All external devices, that is the peripheral devices, are connected to the processor through the input output controller. This provides the mechanism for input data to be received for processing from the input devices such as the keyboard, the result of computation to be output from the system to output devices such as display screens like the monitor. So what are we saying here? For the processor to be in contact with input data provided by the input devices, it has to pass through the input controller as well as the result of computation before being displayed or outputted to the user must pass through the input output controller as well. In contrast to the main memory, secondary storage cannot be accessed directly by the processor. Remember in our last lesson when we look at the memory hierarchy, we saw that the secondary devices are at the bottom of the pyramid. So, not being accessed directly by the processor, they need input-output controller in order to be connected to the processor. So we are seeing here that the input-output controller helps the secondary storage devices, the input devices, as well as the output devices to be connected to the processor. The main memory, in contrast, are directly connected to the processor. A physical port, like a USB port, is used to connect a keyboard to a computer. On the controller a physical port on the controller provides a connection for the peripheral. That is, for you to connect your phone, for example, your phone that has a USB cable to the computer, you need a physical port. The peripheral device has a cable or a connector to connect it to the port that we are talking about. The input-output controller circuitry facilitates the exchange of data in the form of electrical signals between the processor and the peripheral. So when you are connecting your phone to your computer through a USB cable, it is the input-output controller circuitry that facilitates the exchange of data, and that is done in the form of electric signals. The controller then translates the signal into the correct form. When we talk of the correct form, we're talking about the form that the processor will be able to understand. The peripheral device almost certainly operates at a much slower speed than the processor. The interface provides a buffer so that the display timing requirement can be satisfied. Now you might ask yourself, what is a buffer? So in this context, the buffer is being used here because the peripheral device is having a slower speed as compared to the processor, which is fast. So in order for us to cope with this speed, the interface provides a buffer so that the difference in time requirement can be satisfied. A buffer is a temporary storage area in memory that holds data while it's being moved between devices and processes. So that's the use of a buffer. Each peripheral device can have its own input-output controller or can share a hub controller, as in the case with the USB. When we talk of sharing the same hub controller, what are we talking about? If you take, for example, with a USB key, you have your Android phone. You have, again, I will take an example with, let me say, a camera. You realize that each of these devices I listed can use the USB port of the computer that we call a hub controller. That is, you just if you have your cable, you can come and plug directly on it. But now they are specialized, as you see. Large desktop computer usually have slots where additional specialist controllers can be added. You see that in this new brand laptop that we have and some desktop, you have the Type C port on it where you can connect your phone, and we have any other type of slot. We have the one for the memory card and all the rest. So those are the different ways by which peripheral devices can be connected to the computer. When a new peripheral is added, a device driver is also needed. I'm sure you know what a device driver is for those of you who already passed through software. But let me just refresh your mind. A device driver is simply a system software that enables the operating system to directly exchange with um, peripheral devices. So if you plug a peripheral device on a computer and it is not giving, then it means that either one of the possible errors is that the device driver is not, for that particular peripheral device, is not installed. That is it. It is the case for printers, for scanners, even sometimes for some USB devices. Instead, to allocate time to processes that are deemed urgent, devices uses interrupt. That's what I mean. So there is not, I don't think there is a particular way to allocate time for urgent tasks. Yes, instead you have priority tasks, but there are some tasks that no matter their priority level, they need to be executed over others. And such devices take the attention of the CPU through interrupts. An interrupt is a signal that is sent to the processor to request immediate attention. When the processor receives this request, it suspends what it is doing and runs the process associated with the interrupt. So that's how it is. So if I have a particular peripheral device that needs immediate attention, it will send an interrupt signal to the processor, and the processor will immediately leave what he is doing and move to where the signal interrupt was launched. The operating system will have an interrupt service routine or interrupt handlers designed to process each interrupt. An interrupt service routine is a mini program that has been designed to respond to an interrupt request. So what happens with interrupt? The first thing that it has to do, we're talking about the processor, is to save the state of the currently executing process. Then it calls a subprogram to deal with the specific type of interrupt. When the subprogram returns, the interrupt handler restores the state of the process that was executing when the interrupt occurred. So what are we saying here? If the processor is currently working on process A and process B sends an interrupt, then the processor will first of all save the state of process A. That is, I was at this particular level. Let me save this state. And that it saves like a restore point. So it saves the state of process A. Then it sends an interrupt service routine to actually solve the problem of process B. And once that problem is solved, the processor comes back on process A and continue with the execution. That is how it happens when an interrupt signal is being sent to the processor. Interrupt service routine can be built into an operating system or provided via device drivers. Now, apart from interrupt, we also have what we call polling. This is a process where the CPU or a controlling program repeatedly checks a peripheral devices at regular intervals to see if it needs service, has data, or if a specific condition is met over and over. So what are we saying here? In an interrupt, the process, as we saw, the processor is on process A, and if no signal occurs, the processor will continue execution of process A until it ends. Whereas when it comes to polling, the processor is on execution of process A, but regularly checks the state of process B to see if there is a particular data that is ready, if a condition is met, or if it needs service. Now let us see what happened in polling. In polling, one device designated as the master repeatedly sends messages to other connected devices to check their status or determine if they have data to transmit. Communication is centralized and controlled by the master. That is how it happens in polling. In contrast to interrupts, where the device signals the CPU only when needed, polling is a simple, software-driven method for input-output management, often used for tasks requiring consistent checks like reading sensor data, but can be inefficient due to wasted CPU cycles when devices are not busy. So in this last point, you have the advantage of polling over interrupt and the advantage of interrupt over polling. So, dear students, I hope you understood this brief lesson on input-output controllers. You saw how peripheral devices interact with the CPU, either through polling or through interrupt. And I hope you enjoyed the lesson. In the next lesson, we are going to introduce uh, a new lesson on computer organization and architecture, which is the second to the last lesson for the chapter. And from there, we shall move to the last lesson, which is addressing mode. And then we shall conclude with the chapter. And concluding with the chapter means what solving questions and providing a link to an online MCQ. Thanks and see you in the next video. Do not forget to like, to subscribe, and to share for our community to grow.